example 5, notice we've got this triangle and angle L subtends the diameter. So we know angle L is a 90-degree angle. And since angle L is a 90-degree angle, that means angle M and angle K have to add to 90 degrees. So we're going to say 5x minus 4 plus 8x minus 10. This time they equal 90 degrees. And now we're just going to solve that equation. And so when we do that, combine your like terms, we get 13x minus 14 equals 90. And then add 14, divide 13, x equals 8. And then I want to find the measure of angle K. So the measure of angle K is 5 times, in this case, 8 minus 4. And I'll end up with 36 degrees. And that's our answer. Angle K is 36 degrees. Now, on our next problem, we have this trapezoid, which is a quadrilateral that's inscribed in a circle. So that tells me that if I'm looking for my angles, in this case, let's look at angle F. I know angle F and angle D, they're opposite of each other. They have to add to 180. So we're going to say 3y plus 4 plus 5y plus 16. My y's look like g's, don't they? Equal 180. Now, if I add those up, I get 8y plus 20. And that's going to equal to 180. Well, subtract 20 from both sides. 8y equals 160. Divide both sides by 8. Y is 20. And then I want to find the measure of angle F. So I'm going to say the measure of angle F. I'm going to replace y with 20. So I'm going to say 3 times 20 plus 4. 3 times 20 is 60 plus 4. I get 64 degrees for the measure of angle F. I'm going to find the measure of angle G in a similar fashion. I'm just going to start here with G and E have to add to 180. So we'll say 3x minus 16 plus x minus 4. That will equal to 180 degrees. And then if I combine those, I'll get 4x minus 20 equals 180. Add 20 to both sides. 4x equals 200. Divide by 4. X equals 50. Then to find the measure of angle G, I just substitute in 50. So I'll go 50 minus 4, and that will be 46 degrees. And we had to do two parts there, G and F. Now we're going to move on to tangents. A tangent is a line that touches a circle but doesn't go inside. So if I have a circle and I draw a line that touches the circle but doesn't go inside, that's your tangent line. And your point of tangency is where it touches. A common tangent is where you have the same line as tangent to two circles at the same time. We have internal and external tangents. Now, we do have a couple theorems that go along with this, but it's easier to see it, I think, with the visualization. And let me see, what did I do with it here? No, I don't want that one. I want Chrome. There we go. And get out of there. Okay, the first one is our tangent radius theorem. I don't like Chrome with these ads anymore. I have to start using something else. And we got a radius and a tangent. And notice it forms a 90-degree angle. It doesn't matter where I'm at on the circle. It's always going to be 90 degrees. And that's why it'll always be a 90-degree angle. My other one, let me see, how do I get back here, is if I have two tangents from the same line. Notice these aren't common tangents. These are two different tangents drawn to the circle. If I measure C to D, notice I get 2.9611. If I measure C to E, I get the same thing, don't I? And once again, let me see, can I move these? No, I can't. Thought I could. Oh, there we go. If I move them, it doesn't matter where I move them to. Notice they're always the same.